Hello everyone, good morning. I hope all you doing good. So today we are going to do actually the application of triple integral. So by using triple integral, we calculate the volume of a solid. So here is the question. So find the volume of the solid bounded above by the sphere x square plus y square plus z square equal to 100 and bounded below by the cone z square equal to x square plus y square. So we have a solid. Now we calculate the volume of that solid by using triple integral. So here the solution. So first we draw the solid in the xyz space. So here the solution that we are going to do. Let me consider here first x-axis, y-axis and z-axis. So for convenience we are taking like that. This is our x-axis, this is y-axis and this is z-axis. Now the equation we have the sphere, it is clear that the sphere has center at 0 0 and radius 100. Radius is 10 because we can write this x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square equal to 10 square. So center at 0 0 0 and radius is 10. So if we draw it, then we can see that. So the sphere is something like that. Now let me draw the cone here. The cone that we have. So the cone that we have, this is z square equal to x square plus y square. So if we want to draw this cone, so we have to little bit observe here. So the observation is the following, that if you take g equal to 0, if you take, then we get x 0, y also 0. And basically when you draw the cone here that we get, so it will be a double seed cone. So at 0 it is passing through 0 0, and this side when g increase, so for every fixed g we get a circle. So we get this type of thing. So and also as well as in the below this kind of thing. So the solid is basically here, this is our solid that we have. We will calculate the volume of this the whole this part as well as the below part. So below we have also something like that. So this part, this is our the solid actually total. So if we can calculate the volume of the upper part, the lower part will be the same, because the solid is symmetric with respect to xy plane basically. So if we can calculate volume of the upper part, then we just multiple that volume by 2 to get the total volume. So we focus only on the upper part. So we will calculate the volume of this part only. Now to calculate the volume of this upper part, we basically take the help of triple integral. So this solid, let me call this solid is D. This is the solid D. Now if we take this solid D, then the volume will be what? So the total volume is this equals to, we'll take the help of triple integral. So triple integral all over the volume of the solid D and dV, like that. So now how we calculate this? So to calculate this, either we can calculate this in the term of Cartesian coordinate or cylindrical coordinate or spherical. Here we will take the help of cylindrical coordinate system. So first observe that the solid we have, that solid, if we project on the xy plane, so then what should we get? So to do this, we need to understand about this circle that we have. If we can know the behavior of this circle, then the projection of that circle. If we take here, let me use the different color. So yellow color I am using here. So if we take this kind of circle in the xy plane, so then what should we get? So this yellow circle will, the disc bounded by the yellow circle will give us the projection of the domain. So this is the projection of the domain on the xy plane, or of the solid on the xy plane. So if we know the boundary of the yellow region, so this is nothing but this is a circle, so that we will see the equation. So how we do that? So we solve the sphere and the cone together. So if we do that, then what should we get? If we put in the place g square, x square plus y square, then in the equation that we have here, in the sphere equation, so what should we get? We get x square plus y square and 2 whole into, so then we get here 100. So x square plus y square equal to 50. So x square plus y square equal to, we can think it is 5 root 2 that whole square. So this yellow circle, so this is basically boundary. If we put this way, that here this boundary actually is given by, this boundary is given by x square plus y square equal to 5 root 2 whole square. Alright, now what should we do to calculate the triple integral in term of a cylindrical coordinate? What is the idea behind the cylindrical coordinate? That if you take any point here, that let me take any point in the solid, then what should we do? We will put the projection on the yellow region. So then we get a point here. So for every point on the solid we get such projection. Now what should we do? We join them. So let's say this point is P point and the projection is called Q point. Now this will make some angle with the x-axis. So this angle, let's say theta, and here will be some length from origin to this. So this is, let's say, theta, and this length we called r. Now if we move the point P on the solid, then the theta will move from 0 to 2 pi and r will move from 0 to up to the radius 5 root 2. So in term of cylindrical coordinate, cylindrical coordinate, what should we get? The domain how looks like. So we have to observe that firstly, that it is clear that we put x equal to r cos theta, y equal to r sin theta, and we know the range for theta will be in between 0 to 2 pi, and r will be in between 0 to 5 root 2. Now what, we have to see the range for g, where g varies. So if you look at here, then 2 point you are getting, so this point up to this point. So maybe we can use this color, that this point and this point, this is g we get from the equation of the cone, g equal to square root of x square plus y square. So I am putting here, this is called a point, this point should I call a point, and this point should I called B point. For the point A, you know, for point A, the G value if we calculate, that will be square root of x square plus y square, and we already know x is r cosine theta, y is r sine theta, so we get after calculation r square cosine square theta plus sine square theta, so that should will be get r square square root, so r. Now for the point B, what should we get? For the point B, B is on the sphere, so for point B we get G equal to square root of 100 minus x square minus y square. As we seen here that square root of x square, x square plus y square is r square, so it will be 100 minus r square. So this will give you the lower value for G, and this will give you the upper value for G. So in term of cylindrical coordinate, the D can be written as r theta G, such that theta will be in between 0 to 2 pi, r will be in between 0 to 5 root 2, and G will be r to square root of 100 minus r square. So we have written the volume or the solid in term of cylindrical coordinate. Now we need to know how the small volume will change when you write in the cylindrical coordinate. That also we know. We also know that d of v equal to r. So if so dz r dr, I am writing like this, and d theta. Sometimes people write like this, r dz dr d theta. So once we know this, we can now write down the triple integral that we have here, call it is 1, that in term of cylindrical coordinate, and we can calculate the volume. I mean, the integration that we will get here will be easy to calculate, so that we are going to do it. So triple integral d of v in term of cylindrical coordinate, it will be theta move from 0 to 2 pi, r move from 0 to 5 root 2, and G move from r to square root of 100 minus r square, and then here r dz dr d theta. Now we will calculate this integration first with respect to G, then with respect to r, then with respect to theta. So if we do that, so what should we get? We get here theta from 0 to 2 pi, and r from 0 to 5 root 2, and here if we calculate, then r g, so lower limit to upper limit, so 100 minus r square of dr d theta. Now if we simplify, so theta equal to 0 to 2 pi, r equal to 0 to 5 root 2, and here it will be r whole into square root of 100 minus r square minus r this of dr d theta. Now we can separately integrate with respect to theta and with respect to r, because the function can be written, we can separate the function, that's why you can do that. So if we do that, so what should we get? We get theta equal to 0 to 2 pi of d theta into r equal to 0 to 5 square root to r square root of 100 minus r square minus r of dr. So this should be theta is from 0 to 2 pi. Now this, to calculate this integration, before substituting, let me separate this integration, 5 root 2 r square root of 100 minus r square of dr minus 0 to 5 root 2, this is r square of dr. So now next what should we do? This is basically, if we write down, this is basically 2 pi into, this will be whatever we have, we write down like that. So if we substitute here u square equal to 100 minus r square, then from here we should get r dr equal to minus u du, and change will be, when you put r equal to 0, this imply u equal to 10. If you put r equal to 5 root 2, if you put r equal to 5 root 2 here, then 5 root 2 mean 5 root 2 whole square mean 25 into 5, so 50, 100 minus 50, so 50. So you will get 5 root 2 also. So this change from 10 to 5 root 2, and then it will be u into minus u du minus, this will be r cube divided by 3, 0 to 5 root 2. So what should we get here? We should get here 2 pi, and this will be, if you integrate, so it will be 5 root 2 to 10, and then this is u square of du minus, this is if you multiple, then you get here 5 root 2 whole cube divided by 3. So then what should we get? This is 2 pi, and then this is u cube by 3. So this will be 5 root 2 to 10 minus, if you little bit use your calculator, then you can see that this will be, let me use the calculator here. So this will be 5 into 5 into 5, 5 into 5 into 2, so 250. So 250 square root of 2 by 3, this, and then here if you do, then you should get here 2 pi, and then 10 cube mean 1000 minus, this will be 252 square root of 2 divided by 3 minus 250 square root of 2 divided by 3. So if we do, then 200, this is 1000 minus 5000 square root of 2 divided by 3. So 500, if you factor out, then you should get 1005 divided by 3, 2 minus square root of 2. So this is the required volume of the solid that we have. Actually, all right. Oh, okay. We have to multiple by 2. Total volume will be here. One thing I did mistake, that you have to multiple by 2. So the total volume is, given by, so total volume, because we have a part in the bottom side of, or negative side of g axis, total volume will be, if you multiple then by 2, then 2000 pi by 3 and 2 minus square root of 2. So this is the idea how you can find out the volume of a solid in term of triple integral. See, whenever you will calculate triple integral, most of the time either we can calculate using Cartesian coordinate system, or we have to use the polar spherical coordinate system, or cylindrical, and sometime we need to use the general transformation, but that case we not see. In rare case we can see that, but the three are very important: Cartesian, spherical and cylinder coordinate system. Here we use the cylindrical coordinate system. If you try to solve this in term of Cartesian coordinate system, then it will become complicated, the calculation. We take the help of geometry and make the calculation part easy, and we get easily the integration part of this. Thank you so much. See you in the next video. Bye.